In section 4 of chapter 1, we're going to take a look at rational expressions. And often when we think of that, it's actually fractions, but of the more complex form as you see here. One of the qualifiers they're giving us in the early part of the text is that throughout this section, we assume that all denominators are non-zero. That is, your denominator can't be a zero. This, recall, is undefined. So often they put this qualifier in, that the denominator letters cannot equal a zero. Okay, so as we look at example 1, we're going to start off very easy. And we want to simplify this rational expression. So basically what we're going to do here is do some canceling of common factors. Now mentally you might think of 12 as 6 times 2 m, and your denominator as a negative 6 times 3. And notice you now have a common factor of 6 over 6, and this can be canceled out. So your answer then from this becomes 2m over 3. Now we still have a negative sign. Theoretically we can put the negative there or in the numerator, but generally the place to put it is by the division bar, the fraction bar. And when you do your work using these fractions, make it horizontal. Don't make those diagonal lines. Now as we look at example B, we have, let me write it big over here, 8x plus 16 over 4. So this is a binomial, and notice there is a common factor of 8 in each one of these. So we can factor out the 8 and end up with x plus 2. And then now this is in a sense over 4. So this 8 and 4 can cancel out. Take a 1 out of the 4 and a 2 out of the 8. And we're left then with 2x plus 2. Now theoretically we could distribute this and get rid of the parentheses, but often they want you to leave it in this form as we see here. In part C now of example 1, we see a trinomial. And you might say, oh, I can cancel, let's do it over here, I can cancel these out. Absolutely not, because these are terms, not factors. You can only cancel out common factors. So we have a trinomial. Let's factor them. And the protocol would be to put 2 sets of parentheses. Again, you would see if there's any common factor in each term. You would pull that out first. But now in factoring this, generally they're not too difficult. A 12 is a 3 and a 4. That when we FOIL add up to 7 in the middle. And then down below, K and K. A 3 and a 1. And our middle term is a 2, so this would need to be positive, and this would be negative. So now that we have common factors, this factor of k plus 3 and k plus 3 would cancel out, and then your answer then would be k plus 4 over k minus 1. And there's the methodology for doing it. And of course, the work is in our textbook. Now, in example 2, we're asked to multiply. And as we look at the factors, there are no common factors here. So the rule is we just multiply our numerator and multiply our denominator. And that's our answer. That one's straightforward. Now, in the next example, as we look at it, we see in this, and we see there are some common factors in our items here. So let's factor this. This is going to be 3y plus 3. And this 6 is going to be 3 times 2. And 18 is going to be 3 times 6. And we can factor a 5 out of the bottom here. Y plus 5. So now we've factored it quite a bit, and maybe a little bit more than needed, but to show you kind of a strategy that now we can factor out common factors. Now these aren't terms anymore, these are factors. And I could take a 2 out of there and a 2 out of there and get 3. And that looks about the size of it here, except I didn't factor that correctly, did I? Sorry about that. Check your work. And now we see this is going to factor out. Okay, that's better. So on our top, we're left with 3 times 3, which is a 9. And on our bottom, we're just left with a 5. So we were asked to multiply, but often they basically want you to factor and simplify. And again, be careful how you do that. Now in example 3, a little more complex, but again the same principle. We're going to factor our numerator, and I have it done nicely here. And this, in a sense, is already factored. You could put this in parentheses if you like. And then here, we're going to factor this, a 3 and a 2. And then factor this, a 2 and a 1. And if we were to FOIL these, they add up, or they result in this. And now we're going to look for common factors. Well, here this is 1. M plus 2, M plus 2. And that's about the size of it. So no other common factors. So then we could unify by putting them over this. Now normally MATLAB would accept this answer right here, but you see what they did is FOIL this to get this one. Now MATLAB should also accept this answer. And you might say, well, which one do I do? Well, as you do your practice and then later your quiz me, that will determine how you show your final answer. As we go into division, there is a little protocol we need to follow. And the general rule is we always convert division to multiplication. And we do that by rewriting our first item, changing our division sign to multiplication, and then take the reciprocal of our second item. Now, it's no longer division, it's multiplication. So that's the main item of when we divide fractions. We change it from division to multiplication, and then flip it, take the reciprocal. Now, we then see if we can do any cross-canceling. 5 will go into there once, 5 will go into there 4 times, and there's nothing else. So now we go 8 times 4x is 32x over, and I can see I didn't finish that really, 11x squared. We could cancel out some of these variables now. This is x to the first, and this is x to the second. In fact, let me just write it this way to show you. Now, one of the x's could cancel out. One of these x's, wanted to change color, here we go. This will cancel with this. So now your final answer is 32 over 11x. Now, an interesting observation here, I don't know if you're ever going to mention it, but this is not really a polynomial. And you might say, why not? Because it has a variable in the denominator. We don't classify expressions as polynomials if they have a variable in the denominator. It's a little technique. They're not asking for that, but otherwise everything is good. In example B, again, we have a rational expression divided by a rational expression. That is, fraction divided by a fraction. So the rule is we take the division and change it to multiplication, take our second item, take the reciprocal of it, that is, just flip it, and then we're good. So once again, we want to factor, and we factor this into, take out a 9 from each one. This is already factored. And then now we do some canceling. So this will cancel with this. And then I have a, let me put it over here at 9, and a 3 times 6 over a 5 times 12. I'm just factoring that a little bit. Now the 6 will go into 12 twice, and that's about it. So we get the 9 times 3 is 27, and 5 times 2 is 10, and that's what they get to. They're not showing how they canceled here a little bit, but they don't have to show you everything. Okay, we're now going to move on to addition, subtraction. And of course, for these, multiplication and division, you'll be doing practice and quiz me's. Now, the key to adding and subtracting fractions is that your denominators must be the same. So if they are the same, you just add your numerators or subtract your numerators, put it over your common denominator now. So they're going to start us off easy. Here our denominators are the same in example 4. So we add our numerators. That's going to be 15 over 5k. But now notice this is 5 times k, and our numerator is 5 times 3, and this is 5 times k. So we now have a common factor of 5 that we can cancel out. So simplified, this ends up being 3 over k. So we have a common denominator, we add our numerators, then we simplify, and there's our answer. In B, it gets a little tedious, but you want a strategy for doing it. But fortunately, here our denominators are already the same. So what I'm going to suggest when you see something like this, you're going to write all of this over your common denominator, in this way. You're going to go 2x squared plus 3x plus 1. Now put the negative sign that's there up now into the numerator, and put what's after the negative sign in parentheses. Okay? But what's going on here? When you do this from an earlier lesson, when there's a negative in front of parentheses, you remove the parentheses by just changing each of these signs. So in a sense, this will become as we remove this parenthesis, this x squared is going to become negative, and this one will become positive. So I'm just going to erase this here. And now we have put our numerator with the proper signs. We went from subtraction, and now we're just going to combine like terms. Now notice they're showing it a little different way here, but I like this way as well. Now you group like terms, and you end up with this. Now often, I don't know, maybe half the time, you're going to be able to factor this numerator once you group it in this form, and then cancel something out. But here, there is no factoring and no canceling out. This is the answer. When the denominators are same, and it's subtraction, you can, parenthesis, change both of these signs, which is what they're doing here. Okay? Now you might say, if it's all worked out here, why do I do it? And the answer is, I'm showing you some simplification, and if you see it step by step, and if you can follow it, that's, I think, a good thing. So the first thing we have to do here is determine what is my common denominator. Well, I'm going to need a p squared here, because p, for the letters, p squared is my common denominator. Now for the numbers, I have a 2 and a 3, so my common number part of our denominator is going to be a 6. So our common denominator is 6 p squared. And if you can see that, then that's a good thing. Now, what we have to do is make each of these fractions such that their denominators will be 6p squared. Now, we are allowed to multiply anything by 1. For instance, if we had 5/7, we can multiply 5/7 by a 1. But if we wanted our new denominator of 7 to be a 14, what would be the form of 1 that we'd have to multiply this fraction by to make an equivalent fraction? And the answer is it would be 2/2. 2/2 is 1. But now, when I multiply 7 times 2, I get 14. And 5 times 2, I get 10. So I now have an equivalent fraction that came from 5/7, multiplying it by 1 in the form of 2/2 to give me 7/10. And you might say, yeah, I could factor out a 2 from each of these and get 5/7. Okay, but we're going to use this concept as we try to change each of these denominators to our common denominator here. We're going to multiply each of these by 1 so that they all end up with a denominator of 6p squared. So this is what we have to do, and our challenge is what form of 1 are we going to multiply this term by? Well, we have to multiply it by 6, this denominator. So our form here is going to be 6/6. We're going to multiply this fraction by a 1 in the form of 6/6. So our denominator now becomes 6p squared, but our numerator is 42. All right, we got our first term. What do we need to multiply 2p by to make it 6p squared? Well, how about 3p over 3p? Because 3p times 2p is 6p. So our numerator now becomes 27p. And what do we have to multiply this term by to make our denominator 6p squared? And this one is 2/2. That's the form of 1 we're going to multiply this by. So our denominator becomes 6p and our numerator becomes a 2. Okay, so where are we? Well, we're at this stage here. And now we see we have common terms on top, like terms, so that becomes a 44. Now notice, if this were 28, we could factor out a 2, but it's not. Now in example 2, these get to be quite tedious, but I've factored my denominator because I want to find out what is my common denominator. Now the rule for finding the common denominator when you have items like this, I have a k plus 1 here and a k plus 1 there, and that's used one time in this denominator, one time in this denominator, so I need at least one of those, k plus 1. Now I have here a k minus 1. It's used once here, but not there at all. So I need one of those. And here I've used this one already, one of those, so I need one. And then here I have a k plus 2 that I haven't used. And let's change color there a little bit. So I need a k plus 2. So this actually is my common denominator. I have one of these and one of these, so I only need one of them. One of these, I need one of those. And one of these, I need one of these. Okay. So, what do I need to do? Well, I need to make this denominator the same as this. So I didn't leave enough room here, but I need to add a k plus 2 there on that side. So I have to multiply this by k plus 2. K plus 2 over k plus 2 is that 1. But now we've made this a equivalent fraction. And you might say, what is missing here? Well, I have a k plus 1, k plus 2. I'm missing a k minus 1 here. So now I have my common denominators. This is challenging, and they're starting it off here. Again, this is the common denominator down there. We have to modify each of our numerators so that we have equivalent fractions with the same denominator. So what I do? Now, what do I do now? Well, I have to multiply this. So this is going to give me k cubed plus 2k squared. Okay. Now our minus here. Now I did factor this, and I didn't really need to factor this, but in a sense, over here, what I have to multiply this one by, again, I can make that a plus, put that in parentheses, put a negative out there, and this is going to be k minus 1. So we're going to look at what the book has, because we're going to see what they do there. And you see this one gets quite tedious here. I would have run out of room. Alright, so there's our k minus 1 to make this equivalent denominators here. They're leaving the negative there. They're putting the negative like we had. Okay. Now they're actually multiplying this by this and getting this. Then they're going to take this negative and change all these signs when they remove the parenthesis. Okay, wow. And then they're going to group like terms, and it ends up looking like this. Wow. One example, and you can see this is quite tedious. And it would have taken me quite a time to do it. In example 6, we're looking at something that's called a complex fraction. That is, when the numerator contains a fraction, and in this case the denominator contains a fraction. So what's the strategy for this? Now there's a couple of strategies, and they're showing you this one, where we look and say, what is our common denominator in the numerator, and what is our common denominator in the denominator? And the answer is it's k. So what we're going to do is multiply each of these by the k, and it simplifies our fraction. So we go 6 times k is 6k. And then when we multiply this by k, the k's actually cancel out, and we're left with a -5. And the same thing here. 1 times k is k. And here, when we multiply the second, we get the k's cancel out, and we get +5. And that's how we do it. They're showing you a little different way, but I think this is the easier way, as long as you know what we're doing. In our textbook, of course, these are the examples that in the past, traditionally, you would do at home in your homework, and bring your homework in, and teacher would look at it. And of course, what we're doing is you're doing your work in your homework log, part of it in lab, most of it at home. And the nice part about it is after you put each answer into the program, you get to see if it's right or wrong, and then also get the tutorial help if you need it. All right, we'll be doing some practice.